Okay, then 10.1.3, they want to know what is the potential difference across the resistors in parallel. Okay, so what do they want? Yes, and that is VIRAP. Potential difference. What is potential difference? It's V. What do we have?
We have ohms.
We have R. We have what is what? Work is, yes, it's P. Yes. It is power, 50 watt. So what equation are we going to use? What formula? Okay, R is the 4.29. P is the 50. So V squared is equal to and then you square root it. Does it make sense? Ten 10.1.4 asks us to calculate the current through resistor R. So they want the current through this resistor. So what do we have? We have V. Is that V the total V? Yes, it is. We want the current.
Yes.
Do we have R?
Yes.
Yes, we can use the total resistance in the parallel circuit because the complete current goes through the parallel circuit. Four. Okay, so what formula are we going to use? R is equal to V over I. We know what R is? We know what V is? We want I. So then I is equal to? It's 3,41 amps. Yes. Yes, you cross multiply. Okay, so now they say the switch in the circuit is opened, meaning that this whole part falls away. Okay. And then they ask, how will the reading on the voltmeter be influenced? Increase, decrease, or remains the same? Why? So the resistance went from 4.729 to 6 ohm. So the resistance increased. The resistance is directly proportional to the potential difference. So the potential difference also increased. Okay, so then they ask us to explain the answer. Okay, so now we're going to explain since R increased from 4.29 ohms to 6 ohms. And R is directly proportional to V. The potential difference will also increase. Do you understand?
Yes.
Then 10.2 asks, a geyser labeled 2000 watt is used for an average of 5 hours per day with a cost of 80 cents per kilowatt hour. And I want to know what is the energy used by the geyser for 5 hours per day. So what do they want? Energy. Energy is the same as let's go see. Energy is the same as what? Not what? Work. Sorry. So we're going to use, yes, energy in joules. So we're going to use that formula. P is equal to the work per time. We have the P is 2000 watts. We want the work or the energy, and we have the time. The time is 5 seconds. 5 hours, but we want it in seconds. So you're going to times 60, then it goes to minutes, then you're going to times 60 again to go to seconds. Or you can just times 360.
Then do we divide the 2000 by the 1?
No, you multiply because it divides with the W. So it multiplies with the 2000. .2.2 now asks what is the cost of electricity to operate the geyser for 30 days. Yo. Okay, so they want the cost for 30 days. To get the cost, we need to times the kilowatt hour with the cost. But we don't have the kilowatt hour yet, we only have the watt and we have the time. So we're going to use the power times the amount of hours that it's operated at. We want kilowatt hour. To get kilowatt hour, we need to times the watt with the hour. Kilowatt times hour gives kilowatt hour. Okay? We have power, but we have it in watt. We need kilowatt. So we divide by 1,000. It's going to be 2,000 divided by 1,000. Times we have the time, we want it in hour, it is an hour, so we can just use the 5 hours. And then we get 10 kilowatt hours per day. They're asking for 30 days, so we need to times it by 30. Ten times 30 is 300 kilowatt hours per month. To get the cost, we're going to times the 80 cents by the 300 kilowatt hours.